Hello, these are the notes for Lesson 7-2, Solving Systems by Elimination Using Addition and Subtraction. So this will be technically the third method that you are learning for solving systems of equations. Remember, graphing is one method, and we just took that and made that into its own unit. But in this unit, you're learning the three other methods, and you just learned substitution. Now you're going to learn one form of elimination. That's elimination using addition and subtraction. So, what is elimination? Well, elimination is when we add or subtract the equations to get rid of one of the variables. You maybe have never thought that we are able to do this, but when we have our two equations in the same problem, our system, we are allowed to add or subtract the equations together in order to get rid of one of the variables, so that then we can solve for the other variable. And a little hint here is that you can use elimination, especially when you have coefficients that are the same number. And remember, coefficients are numbers that are in front of letters. So like in example 1, the numbers that are in front of the x's are a -3 and a 3. That'll be a good thing. Those are coefficients. The y's also have coefficients, 4 and a -6, but those are not the same number. So we won't use those. Well, we'll use them, but I'll get to example 1 in a second. But it'll be really nice that in example 1, there's a -3 in front of the x and a +3 in front of that x. And so, as we get to example 1 here, we'll just dive right into it. We can, in order to eliminate the x, well, you can add these two equations together, because you know that a -3 plus a 3 equals 0. So if you just add the equations together, then you're going to eliminate the x's, which will be really nice. Now, as you then continue with the problem, so we're adding these two equations together, you just have to be really careful as you proceed. So with your y's, you have a 4y plus a -6y. So that's 4 plus -6. And that is -2. So that's a -2y. And then equals, and you again add with your 12 here and your 18. So 12 plus 18 is 30. Yeah. And then you proceed to solve for y. So we eliminated the x, so that all we have left is some y's, and now we want to get the y by itself. So you divide by -2. And you get y equals -30. Now, you still have to go back and figure out what x equals. And you have some choices. You can put the number that you just got for y equals -15. You're going to basically use substitution again, because you're going to put that in place of y in either of the top equations. You can use either one. I usually just pick the top one, unless the bottom one seems easier. In this case, I don't think it's going to matter either way. I think they're going to be both the same difficulty, which to me isn't that hard either way. But you just plug in your -15. I'll put it into the top one for y. So that is going to give us, I've got to remember what was there, -3x plus 4 times -15, because that was y, and it equals 12. Let me draw a little line here. I'm getting over in example 2. Okay, so now we just go ahead and solve for x. So now you have -3x. 4 times -15 is a -60, so I'll put -60 equals 12. Add 60 to both sides. So -3x equals 72. And feel free to use your calculator as you are, working with your positives and your negatives. And as you are doing a little bit of adding and subtracting and maybe some dividing here, as we divide by -3, you should get that x equals -24. So now that we solved that, we just do our last step of writing our solution as an ordered pair. Since we got a solution here, that means that the ordered pair -24, -15 is where these two lines would cross. So I hope you, again, are a little bit grateful that we're not graphing these because they wouldn't cross on our graph probably unless we used an actual large piece of graph paper and used the whole thing. And even then, it might not go out to -24 and down to -15. So this is why we have other methods and why we separated the graphing unit, the graphing section, from the 3 other methods of solving systems. So this is where they would cross if we were to graph them. And again, that just means that if x is -24 and y is -15, then that means both of our original equations are true. You could plug in -24 for x and -15 for y, and that, do a little math there, and it would equal 12. Same way with the bottom equation. You could plug those numbers in for x and y, do a little multiplying and subtracting, and you would get 18. And that's the only ordered pair that makes both of those equations work. No other numbers would make those 2 equations work. Okay, so we just went right in there. We eliminated, in that problem, we eliminated our x's because they had the same coefficients. Their coefficients were the same, and they were just opposite signs. And so we added them together because we knew a -3 plus 3 would give us 0. In example 2, we have some choices. You can actually eliminate either the x's or the y's. When I do this, I look for coefficients that are the same number, which all of these coefficients are 1. Remember, when you don't see a coefficient, you don't see a number in front of a letter, there's an invisible 1 there. So all of them are 1. Well, I could eliminate the x's, but I would have to subtract if I eliminated the x's, because I'd have to take, it's a 1x. To get rid of it, the 1x on the bottom, I'd have to subtract it because they're both positive. So that would give me 0 and eliminate the x's. When I do it, I actually look for coefficients that not only are the same, but I like them to be opposite symbols too. Because then, instead of subtracting, I can add. So you see on our y's, they have, there's a minus y, and then there's a plus y. A -1y and a positive 1y. If I add these 2 equations together, it's going to make it a little bit easier. We'll get to subtracting in a little bit. But if you see coefficients that are the same and they're opposite signs, then you want to add the equations together to get rid of them. So we're going to do that in this one. Let's eliminate the y's. So if I add the equations together, again, that's a -1y plus 1y, which would make our y's go away. But go back to your x's, you have x plus x. Well, x plus x is 2x. And then go over to your numbers, 14 plus 20, that's 34. And then to get x by itself, you divide by 2. So x equals 17. And again, you still have to figure out what y equals, so erase all my scribbling up here. If x equals 17, you can put that into either one of the top equations. I'm going to actually do the bottom one because it has a plus sign instead of a minus sign. That tends to make things easier. So if I put 17 in there for x, then that'll give me 17 plus y, because I don't know what y is yet, equals 20. But we're going to find out soon, because if you subtract 17, then y equals 3. And so your answer is the ordered pair 17, 3. Okay? All right, so in both of those examples, we eliminated the variable that not only had the same coefficients, but also those coefficients had opposite signs. And so when they had opposite signs, to eliminate the y's over here in example 2, we added the equations together. And in example 1, we eliminated the x's by adding the equations together, because a negative 3x plus 3x disappears and gives me 0. So let's move on and try examples 3 and 4, where things are going to change just a little bit. All right, in example 3, you should notice right away that the x's both have 4's in front of them, 4x and 4x. And the y's, they don't have the same coefficients. There's a 2 and there's a minus 3. Those aren't the same. So we want to work on eliminating the x's in this example. Well, if you try adding the equations together, that's not going to work, because that would give you 8x. 4x plus 4x is 8x, and then we'd have to move on, and it wouldn't eliminate any of the variables. You still couldn't figure out what x equaled or what y equals, so we're not going to add them. Well, it should be pretty clear that you have to subtract. If you're not going to add them to eliminate, you're going to subtract, and if you subtract, you'll get 4x minus 4x, which does give you 0x, which is great. The problem is that people tend to not be careful with the next step, and you have to be careful. So I'm actually going to show you 2 different ways to do this, and you can choose kind of which way you would like to do. We have to subtract these equations. There's no going back on that. They have to be subtracted so that the x's will go away. Okay? Every time you go, like when you go over to your y's, you have to go 2y and then go over to your minus sign and think minus and then negative 3y. So that's 2y minus negative 3y, which that minus and that negative would turn into plus, so that would give me 5y. Okay, then the whole numbers are easier because they're not really any negatives, but they could be, so be careful with your negatives there too. But this gives me just 28 minus 18, and that's just 10. So you would get 5y equals 10. Okay, at that point it's not too difficult, but what people tend to do is they tend to ignore the minus sign that they just wrote over here to the left, and they might just put like a 1y or a negative 1y or something instead of a 5y. So if you need to, I want to show you another way you can do it. So over to the right, I've written the system of equations again because I just want to show you the other way. We are still subtracting them. You have to subtract them, but subtracting is the same as adding the opposite. So what you could do is you could change it into an adding problem and then change all of your signs of your bottom equation. So like the 4x is now a negative 4x. The 3y would be a plus 3y. The 18 would be a negative 18. So now you're adding and you just add going down. So the 4x's would still go away because that's 4x plus negative 4x, which would be 0x still. And then as you add your y's, that's 2y plus 3y, which would still give you 5y. And then with your whole numbers, that's 28 plus negative 18, or just 28 minus 18 again, which would give you 10. So for some people, it really helps to think of it as adding, but change all your signs. And so if that works for you, if you understand that, please use that method. Either way, you should get the same answer. But if I go back to the subtracting here on the left, you just have to be careful. You have to say, subtract or minus for every single step. 2y minus negative 3y. You have to be careful with your signs. So if we proceed to solve here, you're going to get that y equals 2, either way you do it. And then the next step is back to normal. You have to plug in that y equals 2, plug it into either one of your equations. I'm going to go back to the original first equation right here and plug it in there because, I don't know, it just seems easier. I think both of them are equally easy. So 4x plus 2 times y, which was 2, equals 28. That's 4x plus 4 equals 28. Subtract the 4. 4x equals 24. And then divide by 4. And x equals 6. So we have the solution that x equals 6, so 6 comma y equals 2. That is our solution. Okay, so let's try example 4. I think this one, it might be real nice to do that changing that we talked about. So here we go. If we, let's see, we have a negative 4m plus 2n equals 6, and then negative 4m plus just regular n equals 8. Don't let the m and the n confuse you. Just like, you know, x, y, like if you say the alphabet, x comes before y, m will come before n. So like the m is like your x and the n is like your y. So when we write our ordered pair, we'll write it with the m number first and then the n number. Okay, but the idea still is that we got to eliminate one of the variables. And you should see here that these are both 4s. In fact, they're both negative 4s. If we were to add the equations together, would that eliminate the m's? And the answer to that is no, because this would be negative 4m plus negative 4m. That's not 0. That's negative 8m. And so that wouldn't make them go away. So we don't want to add the two equations together. We want to subtract them. Okay? Now, if you want to, then you can, there we go, change your subtraction to adding. Let me change colors. You can change the subtraction to adding, but then you have to go through your second equation and change all of the signs. So the negative 4m would become a positive. The n would become a minus n, and the 8 would become a minus. Okay, that way the m's actually truly do disappear. So this would be a negative 4m plus positive 4m. So that's negative 4 plus 4, and that is 0. So then our m's go away, which is what we want. And then as we continue to do the problem, we have a 2n plus a minus n. So that would be like 2n minus n, which would leave us with 1n, or just regular n. And then we have 6 minus 8, which is negative 2. So by eliminating the m's, because they had the same coefficient, we actually, this problem's kind of nice because our n's just gave us n equals negative 2. We don't have to do any dividing. So now I need to take that n equals negative 2 and I need to plug that into either one of the top equations, or I'm going to do the actual top equation. We're going to plug that in for n. So that gives me negative 4m plus 2 times n, which is negative 2. Equals 6. And that's negative 4m. See, 2 times negative 2 is negative 4 equals 6. Add 4 to both sides. Negative 4m equals 10. And then divide by negative 4. Okay, well, 4 doesn't go into 10, but you just want to reduce that fraction. So it would be negative 5 over 2. Just leave it improper. No need to put it as a mixed number. Just make sure it's reduced. You don't want to leave it as just 10 over negative 4. You want to reduce it to negative 5 over 2. And then, again, the last step is to write the ordered pair. So that would be, let's see, the m would come first, so negative 5 over 2, comma, negative 2. That would be where these two lines would cross if we were to graph them. which would be kind of hard to tell on a graph because how would you know that your dot or your point where they cross is right there at -5/2? That would be kind of hard. Okay, let's do some word problems so we can practice using this method a little bit more. All right, so problem number 5 here. It says 4 times one number minus 3 times another number is 12. 2 times the first number added to 3 times the second number is 6. What are the two numbers? Well, we know that with word problems we need to define our variables, write a system, solve it, and write our answer in a sentence. So for this one, the two variables, let's say x and y, well, it's just looking for the two numbers. So this isn't technically like a real world problem, but it is a word problem. So what are the two numbers? So x is going to equal the first number, and y will equal the second number. And we do have to keep them straight because the sentences could be confusing if we don't read carefully. Okay, so the first sentence says 4 times one number minus 3 times another number is 12. So 4 times one number, we'll say 4x, 4 times x, because x is our first number, and then minus 3 times another number, well that must be y, is 12, so equals 12. And then the second sentence says 2 times the first number, well the first number was x again, so 2 times the first number, added to 3 times the second number, it's 3y, that equals 6. Alright, so with this system, you should see that in front of the y's we have 3's. And those 3's have opposite signs, which is great. So in order to eliminate the y's, we would have to add these two numbers together, because -3y plus positive 3y will give me 0y, which is exactly what I want to do. So we're adding these two equations together. The y's go away. The x's will just give me 6x, because 4x plus 2x is 6x. And 12 plus 6 is 18. And then divide by 6, and x equals 3. So we know the first number was 3. And now, just like before, you just have to plug that number in, that's x, so you plug it into either one of the equations at the top. I'm just going to choose the top equation, because it's there. You could choose the bottom one if you want. You can plug it into the second one if you want to. You should get the same thing for y. So let's see, 4x, so that's 4 times 3, because x was 3, minus 3y equals 12. And then 4 times 3 is 12, minus 3y equals 12. Get y by itself, so take away the 12. So this will give me -3y equals 0. Doesn't happen very often. But when I divide by -3, I'm going to get y equals 0, because 0 divided by anything is 0. And so my numbers are 3 and 0. So I need to write that into a sentence. And my sentence simply says the two numbers are 3 and 0. Okay, not too bad. You can always kind of plug them in and make sure, again, 4 times one number, that's 4 times 3, minus 3 times another number, that's 3 times 0, which is 0, so 12 minus 0 is 12. So you can always go back and check your answers to make sure that they work in both equations again. Alright, let's do one that's kind of more real world, like the car problem that's next. Okay. So it says in 1 year, the U.S. produced about 2 million more cars than Japan. Together, the two countries produced about 22 million cars. How many cars were produced in each country? So they're looking for how many cars each country produced. That's what the question is asking right there. So when we define our variables, let's have x equal the number of cars that the U.S. produced, and then y will equal the number of cars that Japan produced. So write that a little bit shorter. Let's say x equals number of U.S. cars and y equals number of Japanese cars. Okay, now this one could be tricky if you don't realize, who made more cars. Well, it says in 1 year the U.S. produced 2 million more cars than Japan. So that means that the United States made more cars than Japan did. That also is kind of telling us a subtraction problem there. That the United States produced 2 million more than Japan did. So if we take the number of cars that the United States produced minus the number of cars that Japan produced, we'll get the difference of 2 million. Now, I don't need to write 2 million out with all those zeros. Since both of the numbers in this problem were given in millions, I can just use the 2, and at the end, just remember that these are millions. So the difference of what they produced is 2 million. But together they produced 22 million, and together means add. So x plus y equals 22 million. So this is actually pretty similar to, I think, example number 2 we had, where really all of our coefficients are the same because they're all ones. We're going to solve this by eliminating one of the variables. And again, when you have a variable where the signs are the opposite, it's easier to eliminate that variable. So I'm going to eliminate the y's. Since their signs are already opposite, that means I'm going to add them together. And so the y's will go away because that's negative 1y plus 1y, so those will go away. But 1x plus 1x is 2x. 2 plus 22 is 24. And when you divide by 2, you get that x equals 12. So then you have to figure out what y equals. I'm going to go back to the addition equation to do that. So if x equals 12, I'm going to put that in for x. It was 12 plus y equals 22. The math on this one isn't too bad. Subtract the 12. Y equals 10. And then you need to go back and write your sentence. Okay, so I just wrote the U.S. produced 12 million cars and Japan produced 10 million cars. Notice I brought the million back in. If I left it out, that wouldn't really make sense to say that the U.S. only produced 12 cars and Japan only produced 10 cars in a year. That definitely doesn't make sense. So because they were both given to us in millions, then during the problem I didn't need to put all those zeros. But in my answer, in my sentence, I need to make sure the reader understands that, the 12, it's 12 million cars and 10 million cars. So we bring those labels back. Okay, one more problem to practice using elimination by adding or subtracting the equations together. All right, here we have a story problem about a youth group and their leaders. They're going to visit Mammoth Cave. It says 2 adults and 5 students in one van paid $77 in admission fees, and the 2 adults and 7 students in a second van paid $95 in admission fees, and we want to figure out the price of admission for an adult and for a student. So there's my variables. What is it asking for? It's asking for the admission price of an adult and of a student. So let's say x equals the adult price. And y equals the student price. And then each van is going to give us each equation. So the first van, it says 2 adults and 5 students in one van paid $77. So that's 2 adults, so 2x, plus 5 students, so plus 5y. That was $77. And then in the second van, we have 2 adults and 7 students, and they paid $95. 2 adults plus 7 students equal $95. Okay, so luckily with this story problem, we can use elimination because the x's both have 2's in front of them. Since they are both positive 2's, in order to eliminate them, I would have to subtract the equations together. If I add them, that would give me 4x, and that wouldn't make the x's or the y's go away. It would just make a bigger problem. So we're going to subtract, and again, if you want to go through and change all of your signs, you can certainly do that. I'm just going to be careful here as I subtract, and I'm going to make sure I go back to my subtraction problem each time. We have 2x minus 2x, which is 0. We have 5y minus 7y. That's negative 2y. Then you have 77 minus 95. And that, if you need to use your calculator, go ahead, should be negative 18. So this makes it really nice to then just solve for y. I hope you are getting used to this method. Just solve for y, and you get y equals 9. Remember what that meant? That means the student price is $9. But we still have to figure out the adult price, so we're going to take that y equals 9. We're going to substitute it. We're really using both methods here. We're going to put that number back in for y into either equation. I'm just going to go up here to the top one. So when I put that number in, I'm going to get, let's see, 2x, because I don't know what x is yet, plus 5 times y, but y is 9, and then it equals 77. 2x, see 5 times 9 is 45, so plus 45 equals 77. Trying to get x by itself now, so subtract the 45. So 2x equals 32, I think, I hope. If I'm wrong, you get a Jolly Rancher. But too bad, I'm right. Divide by 2. And x equals 16. So now we just have to write our sentence about the prices for each type of person, adult and students. Alright, so I just simply wrote the adult price is $16 and the student price is $9. Okay, I know that was kind of a long lesson, a little over half an hour there, but we got all of the notes done in one video for this lesson. So now you should go on to the practice quiz and try those problems. Remember, if you have questions, get your hand up. If you don't understand anything in the video, ask me in class.